Investors look at this stock exchange ticker tape to gather data and make a decision about whether to buy or sell stocks. But how do they make that decision? Well, increasingly, they and managers of all types are turning to computer programs to evaluate alternatives and assess risks in the decision-making process. Today, we're going to look at decision support software on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by CompuServe, featuring an online reference library, Wall Street reports, at-home shopping, airline reservations, games, and hundreds of other services. CompuServe, helping people get the most from computers. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover developments in computer technology worldwide.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. Gary, I'm trying to decide whether or not to buy this computer. I don't really need it. On the other hand, I kind of want it. To help me make a decision, I happen to have some decision support software with me here. A
Looks
coin.
more like hardware, doesn't it?
Well, maybe it's hardware. Okay. Anyhow, heads I buy it, tails I don't, and it's tails. I just saved myself 1,500 bucks. Terrific. This is obviously a primitive way of making a decision. This has all been changed by computers and decision support software. The first question I'd like to ask you is, what is the difference between decision support software and what we call an expert system?
Well, Stuart, decision support software really has been around for quite a while. There are early techniques called linear programming, for example, used in the transportation problem, moving trucks around, cargoes. What you do is you give it minimum, maximum values, and then the analysis goes through and gives you an optimal solution. You have to provide all the numbers, of course. Now, expert systems are based on rules, for example, where you get a collection of rules, doctors that can do a diagnosis of a certain area, for example, and they'll create a mathematical model, possibly, and use some of the same decision support tools underlying it, like linear programming, for example. Now, the difference is, of course, is the expert systems are very, very tailored to specific areas, such as medical diagnosis. And so it takes a lot of effort to put those systems together and a lot of work to get them to work right. So we don't see as many of those. Decision support software, that's sort of a fundamental tool that everybody can use.
Well, our focus today is on decision support software, and we'll take a look at several different software strategies, including a decision matrix, a decision tree, and Monte Carlo simulations. Now, to try to better understand that difference between an expert system and decision support software, we're going to start out by taking a look at an expert system developed by some students at Stanford University.
In just the last few years, expert systems have evolved considerably, from experiments in artificial intelligence to practical PC-based tools. At Stanford University, Professor Ray Levitt is teaching students to develop new applications using expert system shells.
We see artificial intelligence programming languages that were developed for the mainframe and required the usual computer science intermediary in a white coat to operate, being able to be used by engineers with only very modest computer background. So we could get rid of one of the links in the chain of developing an application.
With a shell called Insight, Professor Levitt's students have created expert systems like this Seismic Advisor that provides solutions based on a limited number of selections. The user answers questions about the physical attributes of the building based on a scale of probability. In response, the program will determine the feasibility and probable cost of making the structure safe. If the user needs more information or does not understand a query, he can call up an explanation screen.
The user is interacting with a knowledge-based system, which based on the user's responses will call other programs, either database searches or some computational programs, possibly some graphics, and then return the control back to the expert system. So we're finding that the expert system programming shells, such as the ones I showed you earlier, are very useful tools. They're sort of fourth-generation languages, if you will.
Joining us in the studio now is Mike Doyle with Kepner Trigo Incorporated, and next to Mike is Bill Barton with Palisade Corporation. Gary?
Mike, you have a product called Decision Aid 2, which is a decision support software package. What's a typical customer for that package?
Typical customers would be middle managers in R&D and manufacturing.
And it's to help them make their decisions about how they allocate resources and things of that sort?
Right.
Okay.
Right.
Can you show us what it's about?
Surely. What I've done is brought up the screen, and what it does is go through a series of steps here that would result in coming up with the best balanced choice here at the bottom. What we would do in moving through to this particular point would be to list our objectives and break them into musts and wants. One of the critical things, or one of the key things, is in the weighting objectives, and we can take a look at that. The purpose of this is to give a weighted value to the want objectives or the benefits of the decision. We use a 10-point scale here, and in going through, we would determine the most important want, and then go through and compare the others to it. And goes down this. What this does is
Just to set up the example real quickly, what are you trying to answer here? What question?
In this particular decision here, it is to select a method to increase market share
For a
photochemical company.
Okay.
Okay. And what this does is to give that relative separation there, so that we're not giving an abnormal weight to a lesser, an objective of lesser importance.
So, Mike, are these objectives already built into the program, or do you enter them like you would?
No, you wouldn't enter the objectives, what the outcomes of the particular decision that you're trying to make. Okay. Once we've done that, we would move through listing our alternatives. And then the next thing that we would do would be to get down over here to taking a look at screening the musts. The purpose in screening the musts is to basically make a separation between those that must be included in whatever alternative you finally select, and others which you're looking for to get particular degrees. So a lot of times government regulations and things like that, if for example, it didn't measure up to that 2.0 there as far as the market share, then that would be eliminated as an alternative.
So you've established
Okay.
some rules, say that the market share must increase by at least factor of 2.
Right,
So, okay.
right, okay. Then what we would do is, after we've completed that, we would go back, and the next step would be to move over here to compare the wants. And what we do in comparing the wants is to establish a numeric value to what we've already established a relative value. Now what we're going to do is to take each of the alternatives and screen it against these want objectives to find out just how well it meets that. Okay, we've completed that. We would go back, and any decision is jeopardized severely if we do not determine what the risks would be involved in. So this process goes through assessing what the risks are and determining what actions can be taken. And then the final thing here would be to make your final choice, which would bring up on the screen all of the alternatives that you have selected here, showing the one which gives you your highest weighted score with the worst risk that was involved in each one of those, and assesses the probability.
So lower price per unit was the optimum choice here, a little bit ahead of advertising with the risks identified with it.
And certainly in a range of recommendations, we may be looking at
Mike,
the
can I
top
ask you to
3.
pass the
Sure.
keyboard over to Bill
Okay.
a second? And Bill, if you can bring up at risk. How long normally would it take somebody to run through that process? We whisk through just a real quick little summary of that.
My experience in working with clients is that depending upon the nature of the decision, could be anywhere from maybe a couple of hours to a couple of days, depending upon the data that had to be gathered.
And how sophisticated does the user have to be to work with this and establishing all those criteria?
Well, one of the real beauties about this is that you don't have to be very sophisticated. The program is very straightforward and allows people to mostly concentrate on data and not have to worry about the complication of running the program.
And what's a piece of software like that cost?
This is $250.
How you doing, Bill? You almost up here with at risk?
Yes.
Speed typing there? Can you talk and type?
Yeah, sure.
Tell us a little bit about at risk.
At Risk is a Monte Carlo simulation package that's basically intending to do a large number of what-if scenarios, thousands even, and then summarizing those results meaningfully. What you can see here on the screen is a very simple finance model that
It is a 1, 2, 3 spreadsheet we're looking
absolutely, and that's a very good point to make, because this is a true Lotus add-in, meaning that you are generally working in 1, 2, 3 as normal. The capabilities of the add-in are there when you need them. Otherwise, it's 1, 2, 3 as needed. What you can see where the cursor is located is a design cost entry, and you'll notice up above that it's been entered as at uniform. This is one of a set of special at functions added by at risk to 1, 2, 3 to allow you to do something very special, and that is to add or enter a range of possible values to a single cell. And what that essentially is saying is that the value in that cell could range with equal probability between 30,000 and 70,000. At-risk gives you a whole range of different distribution types, and you can add as many as you want to a given spreadsheet.
Okay, so how do you get into at-risk then?
Well, here it is right here. A special menu comes up with a hotkey. This lets you do all of the settings that you need to start off a simulation. What I've done is set the parameters here ahead of time, the sampling type, number of iterations, so on and so forth. And let's watch what happens. Values are being sampled randomly for each cell that contains one of these distribution at functions. And then the sheet is being recalculated. What happens then is that the at-risk add-in collects all the values for cells you've chosen for output, stores them on disk, and then passes them after 123 is temporarily shut down to this companion routine, which is essentially our output routine
and what
called
does this tell
risk
us?
graph. Well, what this is doing is summarizing all of those thousands of what-if scenarios that were run by the computer, and it's presenting them graphically as a probability distribution.
And it claims I ran 2,000 trials? Is that what
Not just while we were running. These were previous results.
Okay.
We just ran a small sample
Okay.
earlier. This is a result from earlier on. And the basic way that the decision maker would interpret this result is to recognize that on the x-axis, this bottom axis here, are all the possible outcomes. And the heights of the bars give you some indication of the relative probability of them occurring. Now, at-risk does more than just give you nice graphics for a distribution. It also gives you a lot of supporting statistics, such as minimum, maximum, mean, and higher moments, and plenty more. In addition, you can also go in and change the appearance of your spreadsheet. What I'm going to do here is increase the number of bars. This is actually letting you go in and control the level of detail that you're going to view. Another very important feature that at-risk has is that it lets you select for output a range of cells. If you do select a range of cells like I did here, it goes in and calculates a distribution for each cell and then displays them graphically and actually summarizes them, showing you just the trend of the mean, one standard deviation either side, and then the 5th and 95th percentiles.
Bill, just about 15 seconds left. How would a typical user use something like at-risk?
There's a whole range of problems that would be applicable to it. Anything that you basically are doing in Lotus would be fair game. Investment analysis, insurance loss projections, so on and so forth.
And what you want to do with a range of values rather than a specific value in a projection.
One final comment. Once you're done, you automatically are back to 1, 2, 3 where you left off.
Gentlemen, thank you very much. In addition to decision support systems and expert systems, we sometimes hear the phrase knowledge engineering. Well, Wendy Woods has a report on a product of knowledge engineering from a company called Technology.
Technology makes what's considered to be the Rolls-Royce of decision support software, the expert system. Its expert system shell can be made into a computerized expert on virtually any subject, like this one, Nervous Shock Advisor. Created by the University of British Columbia as a teaching tool, this program asks questions, analyzes the answers, and decides whether a client has grounds to sue for nervous shock. Technology's expert systems have also been used for such diverse applications as analyzing brain waves in employee drug testing, and by Federal Express to keep track of the spare parts needed to keep its fleet in the air.
The benefits from an expert system range from what we call human quality improvements. People are trained easier, that makes their job easier, to real bottom line savings. For example, on a shop floor, if you can diagnose a machine problem in 5 minutes versus 5 hours, you've saved an incredible amount of downtime, as well as probably parts. You replace the correct parts instead of randomly checking out different parts and then finding the right one eventually.
Technology has grown from a startup to a firm making more than $20 million a year in just 6 years, which tells you something about the importance of their software tools. As one officer here put it, we finally moved from the Buck Rogers stage into practical application. In Palo Alto for the Computer Chronicles, I'm Wendy Woods.
Joining us in the studio now is Peter McNamee. He's Senior Associate with the Strategic Decisions Group. Next to Peter, Jared Taylor, West Coast Editor of PC Magazine. And Gary, Jared just wrote a feature article in the magazine about decision support software.
So that makes him an expert? Yeah.
I think so.
Okay. Jared, what are some of the techniques that are used in decision support software?
Well, in the article that we wrote in the magazine, and in fact what we're seeing today, there are three different kinds that have recently become popular on microcomputers. One is a decision matrix. That was the first one we saw. The other is Monte Carlo analysis, and what we'll now see is decision tree analysis. And they are applicable to different kinds of problems. And I think it's relevant to say that the first program we saw, which is a decision matrix, is the most inherently understandable. It's a sophisticated way of totting up the pluses and minuses of a decision and drawing a conclusion on the basis of that. The other two are more sophisticated and involve a certain amount of statistical analysis.
Do you have to be an expert in statistics to be able to use those?
You don't have to be an expert. You have to be probably better grounded in statistics to make the most appropriate use of Monte Carlo analysis.
Okay.
But in the case of decision trees, you can have kind of a gut feeling as to, is it likely to go this way or that way?
Okay, Peter, show us a decision tree, and in your case it's called super tree.
Okay, I brought up on the screen here a very, very simple example of a decision tree which we might see in our consulting practice. It's a research and development decision. Basically, you're looking at a research decision. Do you go ahead or not? If you don't, you wind up with nothing. If you go ahead, you might see research success or research failure. With research success, you would probably go ahead, develop it, and then someplace down the line you have a decision. Do you actually bring it to market, or do you just leave it on the shelf? If you bring it to market, the market force, of course, will come back and tell you it's either great, it's okay, or forget it.
Okay.
A couple of numbers you can see here, some probabilities. There's a 40% chance of success, a 20% chance of a great market. Those basically come from the decision maker's experience, his state of knowledge, his gut intuition. Ordinarily they're not derived, sometimes they are, but ordinarily they're not derived from statistics.
Mm-hmm.
Usually they deal with future events, and it's really your gut level that controls it.
Up here, it looks like you're just multiplying numbers here across the branches of the tree. There must be more to it than that, obviously.
Oh, there's a lot more to it than that. But let me just show you one thing that's quite simple. How do you evaluate three outcomes like this? Plus 30, plus 10, minus 10. You might imagine they're millions of dollars for a big company. Basically what you do is you multiply the probability times the outcome and add them up. 0.2 times 30, 0.5 times 10, 0.3 times minus 10, and you get an expected value of 8. Which is much like if you had a coin flip it at a $10 bill, you'd say, it's worth about $5 to me.
Mm-hmm.
Okay. 8 looks better than the minus 11 you might see, so you would choose the market branch, bring the 8 forward, and again multiplying 0.4 times 8, 0.6 times minus 1, you get 2.6, which from the research manager's viewpoint is the value that he would associate with the venture. Better than 0, probably go ahead.
Mm-hmm.
Maybe some adjustment for risk. That's a whole different topic.
Okay. What else can you show us about how would you'd get into this?
Okay, let me tell you a little bit more about the program. Basically, it has the usual Lotus-like menu for structure. Structure is inputting information. Evaluate. Where do the numbers out here at the end come from? Well, you might have, very much like with the Monte Carlo evaluation, a Lotus spreadsheet. This isn't a drop-in in Lotus, but it runs Lotus or IFPS or Symphony or Multiplan or Excel. And then analyze is trying to milk all the information out of these trees, and in a much larger tree there's a lot of information. Let me just show you one plot. It's done very simply here, and I'll just plot the probability distribution in a histogram form. Oh, tell it to go ahead.
Okay, so you're going to plot the same kinds of outcomes we saw in numbers in that tree before.
Correct. That's exactly what I'm going to do. There's a lot of tailoring you can do to the output here. But this is that same tree we saw before. Here's the histogram, fairly simple form, but we find we always redraw our results afterwards. There is the 60% probability of research failure. Here's the worst of all possible outcomes. Research success, market failure. And here are the good market outcomes. And, of course, with a much more complex tree, this would fill in and become a smooth probability distribution.
Now, Peter, I'm going back to my question. If I look at it as a layman and take a look at these graphs, it looks like a multiplier across the graph. What else is it doing besides that for you?
Well, one thing you can do, aside from just that straight, we call it rollback, multiply across the graphs, you can rearrange the nodes in the tree. And let me just do that here, and then tell you why you might want to do it. Suppose I could go out and engage in a market study and find out what the market really is before I make my R&D decision, before I plunk down my $1 million. Well, obviously that'd be nice. If I know it's going to be a bad market, I probably won't do it. But how nice? How much am I going to spend on that?
Well, what's it worth to pay for that decision?
What's it worth to you? And basically that means I resolve my uncertainty before I make my research decision. And you can notice down here the expected value of this tree, that average number, is $4 million instead of 2.6. So at the most for a market research, you'd spend $1.6 million, $1.4 million.
So you sort of just turn the graph around over the tree.
Correct, and that's the real power of a decision tree. You can begin to ask questions like that, and we find that companies are almost universally putting the money in the wrong bin. They do research on things they don't really have to research anymore, and they miss the obvious. And so this is a way that people can really structure their research effort and decide when you have to live with the uncertainty and go ahead.
Jared, what are the kind of customer caveats here in using decision support software? I mean, I assume there are some.
I'd say the standard caveat is the standard caveat with any computer program, and that's garbage in, garbage out. If you don't think carefully about the information you're putting into the program, you'll get garbage as a result. But I think that one of the really important aspects of all three of these programs is the fact that in order to do a serious decision tree or matrix analysis or set up a Monte Carlo model, you've got to at least have thought about every aspect of the decision. It makes you think logically.
So it doesn't get you out of that decision process. You've still got to evaluate those criteria in a sense.
That's what's called decision support. You know, it's not decision make software.
Right. Okay, thank you very much, Peter and Jared. We're out of time. That's our program on decision support software. Thanks for being with us. Hope we'll see you again next week on the Computer Chronicles.
In the random access file this week, Hewlett-Packard's New Wave is finally out. New Wave is an object-oriented application environment that runs under Microsoft Windows. It was first introduced about 2 years ago. And although the developer kit has been available since March 1988, this latest release marks the first time users will actually be able to use New Wave to work with multiple MS-DOS and Windows applications. New Wave 1.0 sells for $195 and requires a PC with Windows and at least 3 megabytes of expanded memory. Now you can use VGA, EGA, Apple Mono, and multi-scanner monitors on the Mac. A fledgling firm called Lapis Technologies has unveiled a new kind of video board for the Macintosh SE and Mac 2, which allows the Macs to use a selection of different full-page and other video displays. The use of these monitors will enable users to view parts of a spreadsheet or page layout normally left unseen because they exceed the Mac's screen capacity. Display Server, as the program is called, will cost $449 for the SE and $499 for the NuBus version. When is a document not a document? When it's stored in a computer at the White House. In the White House, a document isn't considered official until it's been printed on paper. But several groups are going to court to try to change that. They were concerned by the difficulties encountered during the Iran-Contra investigation. It seems that many communications shared by Oliver North, Robert McFarlane, and Admiral John Poindexter were confined to electronic mail. While some of those communications may yet exist on electronic media, they weren't released by the White House because they weren't on paper, and what's not on paper isn't considered official. As Apple nears the unveiling of its first portable on September 20th, the competition is also gearing up. Atari's Stacy laptop, which is due to ship in October, will be among the main competitors. The ST-type Stacy is supposed to be able to run Macintosh programs with the help of a special cartridge from Gadgets by Small. The $300 Spectre GCR cartridge plugs into the Stacy port and allows Macintosh programs to be loaded and run on the machine. The Stacy comes with one 3.5-inch drive and standard LCD, 1 megabyte of memory, and an 8 megahertz 68,000 microprocessor. The Stacy will have a base price of $1,500 or $2,000 with the optional 20 meg drive. According to a Japanese newspaper, IBM Japan is developing a notebook-sized personal computer and is supplying prototypes to selected customers. The prototype reportedly weighs less than 6 pounds, has a 16-bit microprocessor, and operates for more than 2 hours with full battery charge. IBM Japan's salesmen are quoted as saying their notebook-sized PC will be released and shipped by the end of this year. A Japanese company has developed a computer-based word processor that can handle English, Spanish, German, Russian, French, and Portuguese all in the same document. Conduct Corporation's machine consists of a monochrome CRT, customized keyboard layout, and onboard disk drive. But most importantly, it includes a printer that can print either in Roman or Cyrillic type without the need to change fonts, so that more than one language can be printed in the same document. Initial shipment of the $1,400 machine will begin next June. And finally, just in time for students returning to school, Smith Corona is offering a new laptop personal word processor that fits in somewhere between a typewriter and a PC. The PWP 7000 laptop comes with a letter-quality daisy wheel printer, full word processing, and optional spreadsheet capabilities. It weighs a little over 6 pounds and can communicate via a 1200 baud Hayes-compatible modem. The $900 unit is available immediately. And that's it for this week's Computer Chronicles. I'm Kate McGargy. See you next week.
The Computer Chronicles is made possible in part by McGraw-Hill, publishers of Byte magazine, and BIX, the Byte Information Exchange. In print and online, Byte and BIX serve computer professionals worldwide with detailed information on new hardware, software, and technologies.
For a transcript of this week's Computer Chronicles, send $4 to PTV Publications, Post Office Box 701, Kent, Ohio 44240. Please indicate program date.